which approach is going to make most sense for your audience. Hi everyone, my name is Kim Larson. I'm a client success manager here at Luminoso, and today we're going to go over what you guys need to know about Galaxy and the science that informs it. So today we're going to go over the engine. So what is it that we are using when we use Daylight? And that will help contextualize how we use Galaxy as the window into the engine that informs all the other features and functionality. We'll look at the difference between unique to filter and other filtering approaches. We'll look at a workflow that branches projects, how ignore terms works, and we'll tack on research with emotions and ways we can utilize emotions to understand our content a little bit better. So let's start with the engine stuff. There are 3 primary elements that we'll be using. We'll be looking at what is ConceptNet, what is QuickLearn, and what is WordFreq, and how do all those play into each other for the Daylight outputs. So ConceptNet is that baseline understanding where we've calculated the relationship between words in language. And this was done using ConceptNet. So this is a visual that we have from ConceptNet where we can see this like science kind of physics cluster that bleeds into anatomy, and then there's history, and then there's math, and then it goes into language and different types of language and sports, and it all maps together. And this kind of sets the primer for what allows us to be domain agnostic. This allows you to study some really unique perspectives on things that are maybe outside of standard day-to-day business and get some deeper, richer insights. So from there, we have this workflow that you guys will use. You have the natural language sources, so that could be reviews, that could be essays, that could be surveys, that could be call centers, that could be social media posts, email. Wherever stories are being told, we can pipe that in through Daylight, through the UI or API. That's the data preparation step. And then we take that and we take that understanding of natural language, we compare that to the data that you've uploaded to surface the insights about that data. The AI doesn't necessarily know what your objectives are when you're studying it. It just presents this quick insight on what is in there, and then you guys get to extrapolate that and show it to your stakeholders using the different lenses that we have through the UI. So are you tracking volume? Are you tracking relationships? Are you tracking the sentiment? Are you checking drivers? And that's how you translate it to the internal stakeholders that then turn that into action that you then get to study again, hopefully. So WordFreq is what surfaces the prevalence. So what is used more often in your data set compared to what we would expect to see out in the wild. Here I'm comparing the No Man's Sky game reviews with our own client feedback surveys, and it surfaces, what is uniquely common. In the video game, there's planets, there's updates, there's promises. If you watch the webinar on No Man's Sky, this will all be familiar. And then there's the top concepts by prevalence where you see my name, because you guys mentioned me by name. Thank you for doing that. Continue to do so and giving us more feedback on that. We talk about concepts more often in Daylight domains than I think people talk about concepts in other domains, and the AI surfaces that. Everyone who submits a Daylight survey talks about concepts because it's the core of what we do. From here, we have that QuickLearn technology where we surface what is unique, what's uniquely related to it. So in No Man's Sky, there's a concept of galaxy, and in Daylight, we have a concept of galaxy. On the No Man's Sky side, we can see that galaxy is related to the universe, the solar system, black holes, hyperspace. All these different ways that people talk about galaxy in No Man's Sky is different than how people talk about galaxy in the Daylight context. Galaxy in the Daylight context shows the matches, it helps with the analysis, you're looking for charts. The associations and the conceptual matches in each of these domains are going to be different. QuickLearn is what surfaces those relationships and surfaces the strengths. So from here, one of the things that I think helps a lot of users and analysts is it's easier to be confident after you've seen some examples that are not just your own. So we're going to go over 10 examples of Galaxy, and I'll talk through how I identify the themes using Galaxy, and you guys can use it to kind of inform how you look at the Galaxy view for your projects. So from here, this is our client feedback surveys. In the surveys, the feedback so far is often about the product in this purple section, the relationship with the company, with Luminoso, the general high-level view, and then there's that connective tissue of feelings around it and the connection to each of those elements. So here I'm dragging around sentiment related to themes, related to filters, and on the top we see Kim Larson associated with uploading data. A lot of you have used me to upload data or in some relationship to that, and that naturally clustered the two sections into two distinct sections. The more feedback you produce, maybe we'll see webinar content in here or educational content or partner relationships. The AI surfacing what's in the data, the more things that are covered, the more we'll see. From here, we have nomanssky reviews. So this is the unfiltered nomanssky review data, where we see there's a lot more going on in this player data set, where it has the world building, it has the emotions with relaxing, it has the marketing, it has the development and the bugs. All of these separate into different clusters using the conceptual matches and the associations that we identified in QuickLearn. Talking really fast. Then we have the focus medication reviews. So this is medications according to patients. So WebMD, not necessarily a doctor, but it is a source of where people are talking about their experiences in relationship to medication themes. So here we have the reviews of focus medications, and we can see the purple cluster of what are people trying to accomplish when they take these medications, what are the side effects of having these medications. We see depression, we see headaches, we see mood swings, we see dry mouth, lots of things in the side effect cluster. And then there's the actual medication itself in this yellow cluster. So we see different names of prescriptions, dosages, documents. There's our clustering there. A lot of people have seen our beer reviews. So if you're watching this from the demo or the trial, this is the data set that you've probably seen. And this is where we can see the different clusters of what is being talked about in beer reviews. There's the default of all the different ways people talk about beer in general. So we have the bottle, we have the pours, we have the flavors and smells. And then I filter it for an IPA, which we can see the citrus, grapefruit themes. And then I filter it again for stout, where we see those chocolate, oat, vanilla, malt themes. The associations are still there underneath the hood, but when we filter it, we see what is prevalent in these data sets, and overall. From here, we can see TEDtalk transcripts. We have those scraped, and you can see what language TEDtalk speakers use when they're speaking. It's not necessarily a specific topic. This is general TED Talks. So that'll include scientists, economics, teachers, activists, the whole spectrum. And the language that they use. So they're talking about what's surfacing, emotions, all these things. And you'll see that the clusters are not as continental as we saw in the previous ones, where there was a clear flavor cluster and a clear appearance cluster. The language is more intermeshed. It happens, it's okay. It's just reflective of the data that's being digested. Here we have CASA testimonies. So folks who are quitting smoking and how they accomplish that. And there's a whole bunch of stories in this data set. When they started smoking, when they stopped smoking, how they stopped smoking, why they stopped smoking. This covers quite a bit, and the topic and the language around it is all really seemingly similar, but there's enough of it going on that Daylight can do quite a bit with it. Then we have a favorite of mine, which is the vitamin gummy data set. So this is 5 gummy vitamin brands, very similar to the beer clusters as far as there's like 3 distinct continents, one of them being more concise. So in beer, there's only so many ways you would describe the bottle or the can if you're evaluating the flavor, so that cluster is really concise. Here, the purchasing, the Amazon, that is more concise compared to the vocabulary used to describe the vitamins, the efficacy, the flavor, etc. Finally, we have the elf-on-the-shelf reviews. The language here, again, not as broad as in the other data sets. It is the specific doll that is purchased for these specific holidays and the associations that come out of that. One of the things that I really enjoy about this data set specifically is the association relationship between Santa and behavior. So Santa is a distinct cluster. We can see from the color pigment bleed that Santa is associated with the North Pole, but also behave and behavior stays in that color. It's more associated with Santa than any other concept in the data set. So here we have those. Better.com once upon a time had a massive layoff event that resulted in feedback on Glassdoor. And this shows us what are the Glassdoor reviews. What are people saying about their experience at Better.com? We can see what concepts kind of haunt the CEO concept, and we can also see what kind of clusters around those compensation, the bonuses, the benefits, those cluster together as well. So a whole bunch of domains that we can cover. This is our last one. This is an obfuscated donut/coffee app review data set. And we can see the different clusters that come out from here. So we can see donuts associated with coffee, with ordering. We can see the apps. We can see the emotions around it with the frustration or disappointing, ridiculous. We can see what is related to what from this view. So lots of data sets. If you have more, if you have a data set that you'd like us to upload and review, let us know. I'm happy to process that for you. Hence the name association in the Daylight cluster from the start. From here, once you have your data and your stories, hopefully you also have filters or metadata that you can use to drill down into subsets of your data. So to demonstrate how that works, let's look at comparing by filters. So this is the vitamin gummy data set. On the left, we have filtered to 1-star reviews. And on the right, we have filtered to 5-star reviews and the different language that surfaces in each of these subsets. On the left, we see a kind of big red cluster up here with bottle, melted, seal, melted together, packaging, Amazon, all of that clusters into a theme. And then we have this disappointed cluster, unfortunately do not buy, taste awful, a whole bunch of language around taste and the words that are used when describing taste for 1-star reviews. On 5-star reviews, the themes are the same, but the language within those themes are different. So we see things like yummy, candy, taste really good, curb my appetite from the apple cider vinegar gummies, supplements. There are some things that are going to be similar in both 1- and 5-star reviews and things that are different. Filtering allows us to see what each of those are. Now, recently, or semi-recently, depending on how long you've been around, we introduced unique to filter by rating, which allows you to jump into what is distinct. So these are not themes that are necessarily exclusive to the other, but using the transfer learning that we use to surface what is unique in your data set compared to language out in the wild, that same technology is used to surface what is unique in one subset versus another. So wasted my money and disappointed and mess and refund, that was unique to 1-star reviews. That was just not mentioned. Usually, maybe at all in the other reviews. Occasionally there's a concept or two that will bleed when they mention the other reviews, but this shows how quickly you can get to the insights of your different subsets. Sometimes when you use unique to filter, there's not going to be anything. It's like there's not enough concepts. that can be a good thing depending on the use case. If you're filtering for gender and employee surveys and the feedback is ubiquitous, awesome, right? That is a good insight when no concepts are surfaced. So if we go back to the filter by rating one again, that can kind of compare and see like which approach is going to make most sense for your audience, right? Okay, if you have over time data, that can be really helpful. Back to the nomanssky data because it's storyful data and we have it available, right? It's really good to track things over time if you're interested in understanding trends or evolution or project management or change management. In 2016, in the first 3 months of the game's launch, what was unique to that data set? If we go back to that earlier slide where it has all the themes of the game, people are going to be talking about the mechanics of the game, of exploration regardless. That's baseline, that's the nature of the game. But we wanted to see, well, what was unique to these different periods? Stuttering, frame rate, crashes, frames per second, lag, performance issues, that's something that we want contained in the past tense, right? We don't want that to be showing up. So it's good that that is in the past tense in this data set. Things like comeback, free updates, next update. As more time goes on, if we were to filter this for 2023 and beyond, these may not be showing up as unique to 2018 and beyond anymore. It's all going to be relative. So that takes us to subset analysis. We have filters, we have identified concepts. How do we excavate deeper themes? So this is the WebMD data again. And here I want to do a deep dive on dry mouth. So we select the concept, we went to the Documents tab, we click Create Project, and here I use total matches. So that's going to take, if they mentioned dry mouth, take only those documents or the documents with the conceptual matches and build a new domain, build the new associations around it. Really easy, doesn't always help depending on your use case because sometimes you want that contextual data. When we're curating prompts and we're trying to study like feelings about this pen, for example, I may not have really strong opinions and storyful data about this pen specifically, but if the prompt was describe your experience as a writer, what do you write down, when do you write it down, that can produce more substantial results. And maybe that's a good time to branch. So once we've branched the project, we can see the document count in the top left in the blue box, fewer responses, and different themes. So in this data set, we have focus medications and antidepressant medications. Now we have a subset of, well, which of those mention dry mouth as a side effect or dry mouth at all? And that will filter out some of the antidepressants because dry mouth is associated with focus medications. From there, we may want to scientifically ignore the term. So if we have taken a concept from the science, built a new project that mentions it every single time, it may be pulling in more concepts artificially and make it difficult to identify the themes associated with it. So we may go into the ignore terms, rebuild the calculations, and have things expand. Some of you have done a really good job identifying if you're doing a brand study where everything is associated with a specific brand. When you scientifically ignore it, it disperses the flavor, the packaging, the marketing. It makes it easier to see. So congratulations on those of you who are already using this in your workflows. Another alternative, if you don't want to mess with the science and sever all those associations and conceptual matches, using the active concept list in your visualizations and then ignoring it or removing it from that list may be the better approach. So in this case, I don't want to remove medication or any of the other concepts from the science, from the underlying conceptual mappings. Maybe I just want to hide it from the visualization, because read more, read less, maybe it brings all the ADHD concepts together, but it's not necessarily going to be interesting to my stakeholders, and I don't want them to get distracted. I want them to be making appropriate decisions and understanding the core meaning of what I'm trying to present. So we also have the option to relabel concepts cosmetically. So depending on the data and where you're getting it from, like if you're scraping Reddit data, there may be things that show up that are not appropriate to put in front of CEOs or marketing teams, right? It's the nature of where the data came from and the level of candidness and security that people feel when posting. In this case, I went ahead and edited the word "a lot" because it didn't need to be a single word. I can go in and change that using the concept editor at the top. So this isn't changing the science, it's just changing how we see it. So if you need to white label something, you can do that. And we can also create additional themes. So if you're tracking a larger study, you need to put a bunch of concepts together, we can do that as well. And we'll show how that impacts the axes in just a second. Back in February or March of 2020, we did a Reddit scrape on two big topics. This was the Bill Gates AMA. So Bill Gates goes into Reddit. He says, "It's March of 2020, ask me anything." And Reddit climbs in and they're asking a whole bunch of questions, right? And those covered a whole bunch of topics. So knowing how our science works with the axes or with the vectors and the relationship between words, we are able to put those vectors on an axis to learn more about the data. So in this case, we have societal on one axis and we have individual on another axis. I save a third concept for foundation to add a juxtaposing pigment that then bleeds out. Because the AI understands the relationship between words, I can put the word individual on the y-axis, and the AI understands what is associated with individuality, and I can start to map what are the concerns, what are people asking about that are related to individuals versus economy. Societal is associated with economy. That makes sense. By using three juxtaposing colors and using colors that are more on the primary parts of the wheel, we can look at the secondary colors to see, well, how strong is the association or the mix between the relationship of these concepts. So herd immunity is a kind of in the middle between an individual concern and a societal concern, whereas isolation and masks is more of an individual concern. Testing kits turns out a little bit brown or a little bit muddy because it was associated with the foundation or the Bill Gates Foundation, the Bill and Melinda Gates Foundation, and individual concerns. People wanted to know, Bill Gates, are you sending me a mask? It wasn't a societal concern, it was more individual. So enough about Bill Gates. On the CASA data, or people who were quitting smoking in their testimonies, we put the different concepts on the axes here. What was associated with starting smoking and what was associated with starting vaping, and trying to map, well, when people said starting vaping, what were they saying? Versus started smoking, what were the stories? What happened there? Does the spouse or the girlfriend or the friends, were those associated with one versus the other? And we can develop themes from there. One of the questions that I get pretty regularly when folks are using Galaxy and they're starting to understand this, they want to figure out, well, why is this concept not showing up for the axes? So here we have the diagnosis on the x-axis and the prescription on the y, but we're not seeing our other prescriptions show up in this list. So Ritalin was on the y-axis as a single concept. It maps just fine, but we're not seeing Adderall on the list at first because it was defined with all of the spelling errors that were included in it. When you have multiple concepts in a definition, there's no longer a single vector to put on an axis. It's not a single number anymore, it's a combination of numbers. So if you want to put something on an axis, it needs to be defined by one concept. We also see that we have different options at the bottom for how the concepts are colored. So you can convey, or you can use an active concept list to determine what concepts are going to be presented. But if you want to use a different concept list to determine the color of those concepts, we have that option to do it. In this example, we have the prescription experience cycle. So from symptoms to diagnosis to prescription to side effects, that is what we use to color the concepts in this view, separate from the domain-specific terms that we were mapping and the list of concepts that we want to see in the presentation. All right, emotion wheels. So once you have your data, or if you're still in the process of designing a survey in order to utilize Galaxy, one thing you may want to consider are emotion wheels. How can we figure out how someone feels about something? Because people may not be saying it explicitly. So historically, we've used wheels like this to say, okay, if we want to put anticipation versus fear on an axis versus disgust versus surprise on an axis, we could do that. We demonstrated that we could do that with the Reddit AMA because it understands societal versus individual, right? One of the things that I've seen recently, and I think we alluded to it in the last webinar, is we're working on how can we study students' relationships to subjects. That takes us to the Yale Center for Emotional Intelligence graph with the ruler emotional regulation skill that a school district is working on developing with our students. And it has this 100-point graph with a energy axis and a pleasantness axis. So there's a 10-point scale on energy and a 10-point scale on feelings. And kids can look at this and figure out kind of relative to other emotions, where are they on this list when they're trying to figure out like, well, what am I feeling? Why am I acting this way? So even if they don't have the vocabulary for apprehensive, they can tell, yeah, I'm not anxious, but I'm not quite worried. And so they can pick that word in the middle. From here, they're only picking one word, but as a researcher, as an analyst, I now have a energy number that I can put into drivers, and I have a pleasantness emotion that I can put into drivers. Then we would ask the students like, well, what subject do you feel most confident in? If it's math, all right, let's figure out how you feel about it according to this chart, and then describe a memorable moment so we can figure out where kids are losing their math interest, gaining their math interest, losing their language interest, gaining their history interest. And if we flip it for least confident in, we can also take these emotions and say, well, if you're most confident in something and you feel disappointed or miserable about it, that's going to be a very different experience and a very different action plan than folks who are least confident about something, but they still feel optimistic and proud. All right, so this is going to give that school board some really interesting data that I hope we'll get to work with soon. So from here, tips to improve the performance of your data. So if you don't have tens of thousands of responses for the AI to learn all the different ways that the audience spelt Adderall, for example, there are ways to kind of tip the scales in your favor and improve the science. The first way is to make sure the text is storyful. If you watch the webinar with Mag from Clarteza, we want to make sure that people are describing the concepts in a variety of ways in order for the AI to detect what's being used synonymously. We want to make sure that you are occasionally running spell check if your data set is small. If there's a level of distinction between how people spell something one way and then people who have a different variation of it are describing it a different way, the AI is going to pick that up and think those are two different things. If you need them to be the same, running spell check can help you ensure that the concepts are aligned as needed. And the other thing that we can do is clean out disqualifying answers. So if you have a required text field and people are, working their way around it to get through it quickly, you may see no comment, NA, doesn't apply, nothing. Those may not be the text that you want to analyze. And so if you clean that out, the AI won't factor it into the model, and it will focus on the more qualified storyful feedback. So that goes into where do we fit in this research process, and we're almost done. We'll get to the questions at the end. But the internal stakeholders, the CEOs, the marketing, the research, the folks who are developing the product and making the changes, they're giving you the objectives. Make sure that you're circling back, understanding the true objectives of what they need from the research, and that will help you curate what the questions are. If you're not converting those objectives into questions that will result in the storyful feedback, you're going to have a harder time getting the responses from the external stakeholders. When the external stakeholders receive the questions, they give the feedback. That's where Luminoso fits into this cycle, because we will process what is that feedback, and then you get to find that feedback and turn that into the insights that go into the decision-making process, wherever that may be. So keep that in mind as we work together. So to summarize, the engine, Luminoso has this baseline understanding of language. We surface what is uniquely common in a data set and what is uniquely associated with other concepts in that data set. Galaxy is the window into that engine that you can then use to, surface the themes, surface the associations. Unique to filter takes that a level deeper to let you better understand this different subdemographics. Ignore terms, removes it from the science, turns it into a stop word, and can help distribute or confuse the model, use it responsibly. And research with emotion wheels or emotion grids are an option, and they can be really helpful when used appropriately. So that covers the core content, but I have some extra credit for those of you who are interested with some of our FAQs about Galaxy science stuff. So here we have, back to Elf on the Shelf, mixed language feedback. So what happens when you upload data for an English domain where not everything is in English? We had this issue in this project where some Portuguese reviews were included in the Amazon review scrape. We can see that when we take ELF and we pull it away, there's little to no association strength with the Portuguese in the data set. It shoots to the back because the ConceptNet underneath the hood, there was no baseline associations, and those words were not being used frequently in conjunction with or synonymously as the words in English. So create this little island or isolation. You can avoid this by cleaning the data in advance and making sure that it's all in one language. I did not do that for this data set, so when I was in the other slide, I just used the active concept list, took it out of the active concepts, and I had a clean view. I think I also only used 50 concepts instead of, I think this is 250, which it wasn't very prevalent, so it kind of cleaned out that noise. The other thing I get asked about is Twitter data. I tried it so you don't have to. This is what Twitter data looks like in Daylight. So when you're scraping tweets, we'll see a lot of hashtags, but this also shows that we can handle emojis just fine. I've seen some of you use, if you're studying Gen Z data, if you're doing a mobile survey, if you're scraping reviews from apps, you'll see emojis, and you don't have to teach the AI what those words mean or what those concepts are. The AI is going to pick it up. So what is associated with crying, prayer hands, virus emoji, etc., the AI will figure it out. But this isn't necessarily storyful data, so it will result in stuff like this. Questions? I didn't see any, so I think we may be good to go. All right. Thank you all for attending. We'll wrap up today, and if you need the recording for this, I will post it on YouTube, and you can share, distribute, reference as needed. But good seeing you all today, and I'll see you all next time.